everyone. Today we will be discussing homework number 6, which is a lesson given in the Abacus Getting Started book. First thing we are going to want to do is read the PDF and see what task the assignment requires us to do. First, what we must do, what the first problem is asking for is to solve for a cargo crane, and what we have to be able to achieve is to mimic images 625 and 628 from the Getting Started book. Problem number 2 is asking for the same thing, however, it requires some modifications as it's the same thing, a cargo crane, but it's under dynamic loading. In problem 3, we're asked to describe 2 real-world problems that we believe have the transient model dynamic techniques. So for problem 1, the first thing what we're going to want to do is go ahead and create a sketch. The sketch that was created is right over here. If it opens up on me. Okay, that is our sketch, and I took the dimensions directly straight from the book. So then what we have is 3 parts: a cross brace, a truss, and a truss all, which is basically the truss connected together, both sides of the truss connected together. So first step is to make sure we have all 3 of these parts, and then we're going to go ahead and define our beam section properties. So we're going to come over here and create 2 sections, one bracing section and one main member section. And for our beam section, so what we're going to go ahead and do is enter our Poisson's ratio, and make sure it's all correct. And we're going to do the same thing for the main member, and these are 2 different sections. Next, what we're going to have to do is create a line equation. This will be under your constraints. So we're going to have two constraints, one for tip A, one for tip B. As you can see over here, tip B and tip A. So for tip A, we're going to set a coefficient of 1 and a degree of freedom of 1. And then for tip B, we're going to have a coefficient of -1 and a degree of freedom of 1. So we're going to go ahead and close that out. One thing I forgot to mention is we also need to create a step for this to see the output. So what we're going to go ahead and do is create a time period of 20, a static load, and make sure the incrementation is on automatic. And the only thing you really have to change is the time period. And then the next thing that we had to do was to define our loads and boundary conditions. So to our loads, we're going to make sure it has a 10 kilonewton load going in the Y direction. So once you come over here, you have -10,000 going in the Y direction, as you can see over here. So we can go ahead and close that out. And then our boundary condition, we're going to make sure that this is a fixed end. Now make sure. Okay, yeah, so fixed end, 1, 2, 3, 4, those 4 points are essentially acting like a wall that is connected to. This boundary condition is really helpful because once the load is applied, it becomes uniform across tip B and tip A. Okay, and then next, what we are going to want to do is go ahead and create a mesh. And what we want to go ahead and do is choose it by part and make sure we select our truss, not our truss all, just the truss. And we're going to want to go ahead and apply a global seed size of 2. Make sure that's applied, close that out, and then you can verify the mesh the part. Same thing for the cross brace, seat the part, 2, apply, okay, and mesh the part, and then you can also verify the mesh if need be. Then finally, for this problem, what we need to go ahead and do is go to our job. We have our job over here, crane. What we're going to want to go ahead and do is a data check. And once we do our data check, it will say results. Once the data check is fully complete, you're going to want to go ahead and hit your results and it'll pop up. I'm having an issue where it won't pop up on this PC, and I think that's because I'm I completed this assignment at school, and I'm recording this at home. So I'll go ahead and show you guys that on my submission. So give me 1 second. So here are my results for plot 625 and 628. 625 is up here. 625 was asking us to plot the deformed model over the non-deformed model, and 628 was asking us to plot the bending moment diagram. As you can see, 628 was mimicked perfectly. I was just not able to show the forces being applied on the bending moment. And then 625 was also mimicked perfectly. It was this image, and you can see right over here it was mimicked perfectly. So what we'll go ahead and do is go ahead and get on to problem 2. So for problem 2, what we want to do is take our cargo crane CAE files from the last cargo crane analyzation that we did and import everything back into this model database. We want to keep this because majority of the steps are the same. We just have to make a couple modifications for this to work. So the first thing that we're going to want to go ahead and change is we're going to want to go ahead and go to our steps and change our tip load to extract frequencies. And that was a static type. What we want to do is change the frequency to change the type to a frequency rather than a static load. And what we're looking for is for the first 30 modes. And so for that, what we need to do is assign a value of 30 for that. And then we're going to come over here to our transient model, and we're going to make sure it's a model dynamics. And then our description should be a crane response to a drop load. Our time period would be assigned a half second, and then our time increment would be applied a 0.005. And then what we want to go ahead and do is adjust our load to have an amplitude. So we'll close that, come over to our load, look at our tip load, and you can see the amplitude is set to bounce. Our load is still the same. We just need to change that amplitude to bounce. And then you want to specify that to be 0.25 as well. And then after that, you can go ahead and run your job and submit the data and run your results. Same thing over here. I was not able to compute that on this PC. Only at school I was able to compute that. So I'll go ahead and show you guys my my PDF submission. Okay, so here we have our results for problem 2. We have our plot 7.8 and 7.9 over here. 7.8 is asking to extract the frequency at 1, and 7.9 is asking us to extract the frequency at 3 out of 20. So I'll pull up the textbook so that you guys can see how these relate. 7.8 and 7.9. They're pretty spot on. And then 7.10. This is one of the curve diagrams. So we're going to come over here, and as you can see, we were perfectly able to mimic that as well. So for part 3, we want to close off the discussion, and because it's asking us to describe 2 other real-world problems, and I believe the transient model dynamic techniques would be relevant to a car tire, because a car tire is constantly changing loads depending on driving conditions, road conditions, and speed. So there are many things changing the force and load very fast and consistently. Another real world problem was a charge pipe for a car. This is in particular made for turbo cars. The pipe is made to push more air into the engine block and for more power. And the turbo spins at different rates, bringing in different pressures of air, and that is dependent on the acceleration and RPM, and this all varies on the driver. So that's why I believe these 2 were very good real-world examples that relate to the transient model dynamics. So that's all I had for everyone today. Thank you for tuning into my discussion, and I hope you guys all have a wonderful day.